Alright, question 29 is asking you to find the first three harmonics of a note on a 31 centimeter long string if the waves have a speed of 274.4 meters per second. So the information that we have is that we're going to have a string that has a length of 31 centimeters that we need to convert to meters. So we have 0.31. We end up with a velocity of 274.4, and that's going to be all the information that we have for right now. Now, we are talking about a violin string, and violin strings have the same fundamental equation as open tubes, because open tubes are open-open, strings are closed-closed, so they have the same tendencies. So the equation for strings and open tubes are the same, which means that you will calculate it by doing F sub n equal to n times V divided by 2L, where n is the number of harmonic. Now in open tubes and strings, the n can be any number that you pick, so n is going to be able to be equal to any value. It could be 1, 2, 3, 4, 9,000, whatever you're doing. There's no difference. You don't have to pay attention to any particular numbers for this. Now this problem wants us to find the first three, so we're going to do n1, n2, and n3 in the equation. So f1 is equal to 1 times the speed of 274.4 divided by the length times 2. And that's going to get us a value of 442.58 hertz as our frequency. Now that frequency is going to be the fundamental, so that's the one that is always going to be number 1. We're going to do the same thing for number 2. Now if you notice, the ends are the same, 1, 1, 274.4, and then 2 times what you got. So for this one, we end up with 2 times that value. Now you might notice that 274.4 divided by 2L is basically F1. So that means we can rewrite our fundamental frequency, or our second harmonic, as 2 times the fundamental frequency, because whatever's in the parentheses is the same as the initial value. So we end up with 885.16 hertz as this frequency for the second harmonic. And the third, we can do 3 times the fundamental. So we do 3 times 442.58, and that's going to give us 1,327.74 hertz. So they all differ by the fundamental frequency of 442.58.